This is lesson 6.4, rectangles. Your objectives are to recognize and apply properties of rectangles and to determine whether parallelograms are rectangles. A rectangle is a quadrilateral with 4 right angles. A rectangle is a parallelogram, so it has all the properties of a parallelogram. Opposite sides are parallel. Opposite angles are congruent. Opposite sides are congruent. Consecutive angles are supplementary because 90 plus 90 is 180. The diagonals bisect each other. So all of those are the properties of parallelograms. It also has additional properties. All of the angles are right angles and the diagonals are congruent. Quadrilateral ABCD is a rectangle. Let's answer all of these questions, and remember, for each question, ignore the answer to the question before it and treat it like it's brand new information. Number 1, if the measure of segment AE is 36 and the measure of segment CE is 2x minus 4, find x. Well, those segment lengths are the diagonal halves of the rectangle. And since the diagonals bisect each other, then we know that those two segments are congruent. We can make their measures equal. Add 4 to each side. And divide by 2. X is 20. In a rectangle, the diagonals bisect each other, so those diagonal halves are congruent. Number 3, if the measure of segment BC is 24, and the measure of segment AD is 5y minus 1, find y. Well, in a rectangle, opposite sides are congruent, so those measures are equal. 24 equals 5y minus 1, and solve for y. Add 1 to each side, and divide both sides by 5. So y is 5. In a rectangle, opposite sides are congruent, so make their measures equal. Number 4, if the measure of angle BEA is 62 degrees, find the measure of angle BAC. Well, we're dealing with angle measures here, and if you look, we're dealing with 2 angles of triangle ABE. If you recall that a rectangle has all 4 of the diagonal halves congruent, that means that those 2 sides are congruent, which makes this an isosceles triangle. Since the base angles of an isosceles triangle are congruent, then the measure of angle ABD is the same as the measure of angle BAC. Those 2 angles are the same in a rectangle. And now I have the 3 angles of a triangle, and I know they all add up to 180, so that will be my equation. I'll solve for x, and that will give me the measure of angle BAC. 2x plus 62 is 180 when you combine like terms. Subtract 62 from each side. And divide both sides by 2. So we get 59, so the measure of angle BAC is 59. Remember, because the diagonal halves are congruent, that gives you isosceles triangles in a rectangle. And with isosceles triangles, the base angles are congruent. And remember as well that the 3 angles of a triangle add up to 180. Number 5, if the measure of angle AED is 12x, and the measure of angle BEC is 10x plus 20, find the measure of angle AED. Well, in this rectangle, those 2 angles are vertical angles, so they're congruent. Make their measures equal. Get the x's on one side by subtracting 10x. Divide both sides by 2, and x is 10. Don't stop there though, because they didn't ask what x is. They asked for the measure of angle AED. And the measure of angle AED is 12x, which is 12 times 10 when you substitute 10 in for x. And 12 times 10 is 120. So the measure of angle AED is 120. Label the pieces they give you and find out which rule applies. In this case, these were vertical angles, which are congruent, so their measures are equal. You can prove that parallelograms are rectangles in the coordinate plane. Since the diagonals of a rectangle are congruent, you could also say the converse, which is if the diagonals of a parallelogram are congruent, then it's a rectangle. We can use the distance formula to find segment lengths. We can use the slope formula to see if lines are parallel or perpendicular. So make sure you use the method that they ask and prove that these shapes are rectangles. Graph each quadrilateral with the given vertices and determine whether it's a rectangle. Justify your answer using the indicated formula. For number 1, they give you this quadrilateral. And it says use the distance formula. And since I know that if the diagonals are congruent, then it's a rectangle, then let's go ahead and find the lengths of each diagonal. So when we do the lengths of the diagonals using the distance formula, each diagonal is the square root of 40 units long. So the diagonals of this parallelogram are congruent. And when the diagonals of a parallelogram are congruent, it's a rectangle. So remember, when it says to use the distance formula, check the diagonals of the parallelogram. If they're congruent, it's a rectangle. If they're not congruent, then it's not a rectangle. For number 2, they give us the vertices of a parallelogram and say use the slope formula. Well, with the slope formula, I can see if two sides are perpendicular. To be perpendicular, they need to be negative reciprocals of one another. So let's find the sides of segment AB and segment BC to start and see if those are perpendicular. If they are, we'll continue our way around the parallelogram. So when you find their slopes, you get 3 1/3. But 3 1/3 are not negative reciprocals. And since they're not negative reciprocals, then those sides are not perpendicular. So no, this is not a rectangle. We don't need to check any of the other sides. We know already that it's not a rectangle. So remember the properties of a rectangle. In addition to all of the properties of a parallelogram, a rectangle also has 4 right angles and it has congruent diagonals. Remember that the 4 half diagonals are all congruent. And remember that isosceles triangles are created with those diagonals. Consider all the symmetry, all the right angles, and remember that on the coordinate plane, you can prove whether or not a parallelogram is a rectangle. Use the distance to show that the diagonals are congruent, or use the slope to show that consecutive sides are perpendicular.